So this object is a truncated icosahedron, and I had several goals when I started with this design. Goal number one was that it needed to be parametric, so I wanted to be able to change a few parameters and have the object automatically update. Another goal was that I didn't want to deal too much with complicated formula, and we're basically just using one formula, and that's a fairly simple one to construct this object. And another goal was that I wanted this to be designed with components. So if I wanted to make a change to one component, it was replicated over all the other components, so I didn't have to repeat design steps. And a truncated icosahedron basically has only two different components. One is a pentagon, and the other one is a hexagon. So if we go to Wikipedia and take a look at the regular icosahedron and scroll down a little bit, we see here on the right side a very interesting construction method. It basically uses just three rectangles, and the aspect ratio between the sides of that rectangle is described by the golden ratio, and that's actually that formula that I just showed in Fusion 360. So that gives us the base for an icosahedron, but that's just a normal icosahedron. So now a truncated icosahedron requires a little bit more work, but it's really not that much. Basically, the description is here. You split these edges in thirds and then cut the tip off at 1/3 edge length. And then you basically have your truncated icosahedron. So let's go over how I would do this in Fusion 360. So the first thing we are going to do is, of course, I'm starting a new design, and I'm going to create three user parameters. First, the edge length, and that's actually the edge of the icosahedron, not the truncated icosahedron. And I need the wall thickness, because later on we give those surfaces a thickness. And I need the golden ratio, and that's not going to have a unit, it's just a multiplier. And here again is that formula that we can see here, same formula. And that's all the user parameters that we need. I'm going to make those favorites. And then I'm going to make my first sketch. And I'm going to repeat that 2 times. All right, so now we have our 3 base sketches. These sketches that we saw here on Wikipedia, those rectangles. And I'm going to now create a construction plane on 3 points, so I can sketch on that construction plane. And there's a little danger here. So you saw that when I picked these 3 points to create the construction plane on, that when I create a sketch on this construction plane now, you see that the sketch origin is here. And the problem with that is, if we use that origin to sketch on, then let me just demonstrate. So I'm going to create a line from here to here to here to here. And that's all good and fine. So let me hide those 3 sketches. But if I now change those dimensions here, let's say we change that to 50. So our triangle got smaller, but it doesn't have equal sides anymore. Why? So why is that the case? So when you pick a point in Fusion 360 to create a construction plane on, that first point that you pick is going to be the origin of that sketch plane. And when you then change the dimensions of the geometry, particularly of the sketch geometry that created that construction plane on, that sketch origin remains at that same spot. And in this case, that's actually not so really helpful. So what I'm going to do is I'm going to project this point in here. That's probably an easier way to do this, and delete these constraints here, and then I'm going to just constrain those lines to here. Okay, now our triangle will properly maintain its shape and dimension. There we go. Okay, so if an icosahedron would be all that we wanted to do, then we would basically almost be done. I could go to the patch workspace and create a patch here. Then I would just pattern that patch several times to create an icosahedron. So let me do this right now. Create pattern, circular. And I could mirror this patch over to the other side, but I'm also going to demonstrate that same methodology that I'm going to use later on to actually pattern components. And mirroring components would be not helpful in this particular case. So I want to pattern this, but only twice. And then I would want to repeat that circular pattern, but this time around this axis. And I don't want 3, I just need 2. And I don't need the full angle, I just need minus 360 divided by 2. Oh, I've made a mistake. I need 360 divided by 5, of course. And then I'm going to do that same thing again. Circular pattern, this patch around this axis. I don't need it 3 times, and I need it minus 360 divided by 5. And then I would take those 4 patches and pattern those 5 times around that axis, and then I stitch it, and then I have a solid. Then if I just again wanted an icosahedron, I would basically be done. But and of course this is parametric, right? Just as the sketch updated, this will also perfectly fine update. But as I mentioned earlier, we want to do this with components, so I'm going to have to undo all of this and delete it. And I'm also going to delete this sketch. No, I'm not. I'm just going to create a new component and pull that sketch into that component. And that is going to be our hexagon. So how are we going to divide these into three pieces, three equal pieces? In order to do that, you create a sketch, sorry, a circle. I'm going to make that a construction line. Then I'm going to make that circle tangent to all three of these lines. And then I'm going to sketch a horizontal line that I'm also going to make tangent to that circle. And that line basically divides this into 1/3 up here and 2/3 up here, and I'm just simply going to pattern this line 3 times around that center. And there is the hexagon. But I also need a pentagon. Before I do anything else, I'm going to create a new component and turn these 3 sketches back on. I'm going to do the same thing. I'm going to create a plane through 3 points, and I need to make sure I pick the right points. One is here, one is here, and one is here. Yep. Then I'm going to create a sketch. Project these points into that sketch. And I'm not sure I projected anything. Nope. That's okay. I'm just going to sketch lines. And the same applies here when I change the size here. Let me change that back to 50. These lines are constrained to that origin of that sketch, and I don't want that. So we'll have to change that manually. So I'm going to project this point in here. I'm going to delete this coincident constraint. Oh. And now we have a perfect sketch. And we also do that same thing here. I'm going to sketch a circle in here. Make that tangent to all 3 lines. Okay. Same thing, I'm going to sketch a line. There's nothing for it to be horizontal to, so I'm just going to make it parallel to the bottom line here, and then tangent to the circle. Okay, so now, together with the sketch and the hexagon, I can define a construction line, a construction plane through 2 edges, and I pick this edge and this edge. And that construction line is going to hold my sketch for the pentagon. I'm going to project this line into this at this point. And then again, I'm just simply patterning that line around the center point 5 times because it's a pentagon. So with that, we have all the sketches that we need to create our geometry. So let's start with the hexagon. Just simply go back to the model workspace and create a loft. Turn the sketches off and create a construction plane. And split the body with that construction plane. And then I remove this remnant here. And that gives us our first hexagon. I'm now going to do the same thing with the pentagon. Create a loft. A construction plane, split body with a construction plane. And then remove the remnant. So now we have our base geometry, and I'm just going to hide the construction plane here. And what I'm going to do now, I'm going to turn on the component color cycling, so we see that those are actually different components, and this is actually the pentagon. And now we need to pattern this a few times. So the first thing I'm going to pattern is, first of all, we are patterning components. So I'm going to have to pattern this. Around this axis, and not 3 times, but 2 times, and not the full angle, but 360 divided by 5. And that needs to go in the negative direction, because that's where I want it. Okay, so now I'm going to create another pattern of this component around this axis. So the reason why I'm not mirroring this component is because then in the component list you end up with a hexagon mirrored. If you would make a bill of materials, you end up with hexagons and hexagon mirrored. They have identical geometry but would be different components, and I'm trying to avoid that. And with patterning I can avoid that. Okay, so now I'm going to create another pattern of this and this component around this axis. Also not 3 times, but 2 times, not the full angle, and again the minus 360 divided by 5. And again, a component pattern of those two around this axis, only twice, and minus 360 divided by 5. Okay, so now we have all the instances that we need for the last pattern. We will not be patterning this here and this here, because if we take a look at this axis, that will be our pattern axis. Those are the poles, and they don't need to be patterned. So another pattern, 1, 2, 3, 4, 5, and 6 around the central axis. times, and that gives us our full truncated icosahedron. And I turn the sketches off, and now of course there's still all components that can be dragged around in the viewport, and we use one joint, a rigid group joint, to join all of those together. And this is our truncated icosahedron. And to get to that other object that I've showed in the beginning, this is very simple. I'm just going to create a sketch. Project the outline. Create an offset. Let's give that 2.5 millimeters. And create another loft. And that sketch vanishes because, well, just because. So we turn it back on, create our loft, and then we're going to create a fillet. And I've done this before, so it's already set to rule fillet, all edges, and I'm just going to accept this. And then I'm going to do the same for the pentagon. Activate it, create a sketch on the top face, project the outline, give it an offset, again of 2.5 millimeter, and create another loft. And give it another fillet. There is our object. So now we can actually apply some materials. So let's take the metal, and I think I used the brass, and I used the old brass for the pentagons, the hexagons. And I used a purple, or actually I started with a blue paint, metal flake, and I then edited that to get that a little bit more of a purple color. And now we could actually render this. I'm going to give the environment a darker color, and maybe this will turn out okay. So this is how you design an icosahedron and a truncated icosahedron in Fusion 360.